Find a lab coat inside the locker and put it on. Now pick up the safety goggles and you are ready. Have a look around and identify the different hazards. A sink full of dirty glassware isn't a nice surprise. Make sure you always clean, dry, and put away the equipment after every experiment. Let's remove the glassware. Beautiful, clean and tidy. Let's move on to the next task. For sure, chemicals need to be stored in designated cupboards and not just placed on the floor. This is especially important for reactive chemicals. Flammable liquids need to be stored in fireproof cabinets. Well spotted. Every lab has 2 emergency exits which ensure that nobody gets cornered in the event of a fire. The emergency door isn't any good if it is blocked by objects. Well done. The emergency exits have to always be clear. Any clutter should be cleared away before starting a new experiment, and there should be no hazardous chemicals left on a workbench. Hazard. The fume hood constantly draws air through a filter to ensure that you don't get in contact with dangerous chemicals. The airflow only works effectively if the glass sash is pulled down. Let's close this fume hood. Water relief. Now the air is safe to breathe. Time to take care of the boxes. Click on them to have a closer look. Click on the bottle containing flammable liquid. Well done. The red diamonds are called hazard symbols. Each of them depicts a different hazard. Have a look at the following overview of the different hazard symbols. Click on the bottles to remove them. Let's get rid of this safety hazard. Click on the cluttered workbench to tidy it up. Oh dear, this workbench is a real mess. Hopefully, you will never see something like this in a real lab. Let's take care of the problems one by one. Start with turning off the Bunsen burner. It is very dangerous to keep an open flame unattended. Great. Now click on the object that you should never bring to the lab. Well spotted. Food and drink are strictly prohibited in the lab. Imagine if somebody grabbed the wrong bottle by mistake and took a sip of the toxic substance. There's another object that doesn't belong here. Find it. Exactly. Personal equipment is not supposed to be placed on workbench surfaces. Could you imagine what would happen if this backpack caught fire? Before you touch anything else, you'd better put on some gloves. Click on the gloves box. There is a living organism on this bench. Can you find it? Oh, have a look at this. There is a bacteria colony growing on this agar plate. This might be some dangerous pathogen. We need to use a special bin for biological waste. Discard the petri dish with the unknown bacterial sample in the bio. There is still a protocol from a previous experiment on the table. Clean up the lab protocol. Oops, you just spilled a hazardous chemical. Have a look at the hazard symbol on the beaker. What does the hazard symbol on the beaker mean? Brilliant! This is a corrosive chemical. We are dealing with either an acid or a base. You can use a pH indicator to figure out what it is. You only need a tiny drop of the indicator. Pick up the pipette from the shelf. Now pick up a pipette tip from the box. Draw up a drop of the indicator liquid. Now add a drop to the spill to identify if it's an acid or a base. Fantastic! When you added the indicator liquid to the spill, the drop turned red. This means the spilled chemical must be a strong acid. We need to neutralize it before cleaning it up. Strong acids react with your skin, can cause burns. That's why it's very important to protect your hands with gloves. First, discard the tip in the trash bin and put the pipette back on its holder. Spills of strong acids or bases have to be neutralized before you can dispose of them. Sodium bicarbonate is the chemical term for baking soda. It neutralizes the acid, and the remains can be scooped into a plastic bin and discarded. Let's neutralize this acid spill. Pick up the baking soda. Put baking soda on the spilled solution. Well done. Now put the neutralizer back on the shelf. Now it is safe to use absorbent paper to clean up the spill. The neutralized acid can be disposed of in the solid chemical waste. Usually, the chemical waste is stored in a fume hood. During the cleanup, your gloves got contaminated. You need to dispose of them to avoid spreading chemicals over everything you touch. Click on the trash bin to discard your contaminated gloves. Why didn't you just clean the spill with water? Superb! If you drop water into a strong acid, they react and produce a lot of heat. Put the goggles on the bench. Pour the beaker containing green acid solution into the bottle with the blue toxic liquid. As I said, don't ever try this at home. Oops, this seems to have triggered a potentially dangerous reaction. What should you do now? Put the lid on the bubbling bottle. This should be interesting. It's still bubbling. Take a closer look by picking the bottle up. Oh no, you've got acid in your eyes. Quickly go to the red safety station next to the emergency exit. Quickly push the toggle to rinse your eyes. After washing the acid out of your eyes, you should immediately consult a doctor. Your eyes are very fragile and it is very important to protect them with safety goggles at all times. Why is it dangerous to wear contact lenses in the lab? The chemical splash might get in between the lenses and the eyeball, and stay there even when you start washing your eyes. If you wear contact lenses, what should you not do if a person's clothes suddenly catch fire? The most effective way to extinguish burning clothes is by rolling on the floor. Water is also a good choice if it's in close proximity. If you see a burning person running down a corridor to reach a safety shower, stop them and try to smother the fire. Never use a fire blanket on a standing person. The blanket may create a chimney effect that can intensify the fire and burn the person's face. What would you use if there was an open fire in the lab? Precisely. There are usually two different types of fire extinguishers: CO2-based extinguishers and foam-based extinguishers. The CO2 is compressed inside the extinguisher and becomes freezing cold when it's released. Exposure to the skin might cause serious frostbite. Great job! You're a safety expert now.